everybody once again. So last class we saw what is velocity potential function and stream function. So velocity potential function was represented by pi and stream function was represented by psi, and we saw the properties of velocity potential function and stream function. Now we will move on to the next concept, that is called equipotential line. Now, what is equipotential line? It is a line along which the velocity potential pi is constant is called equipotential line. That means when a line is drawn, everywhere throughout that line, your velocity potential will be constant. So, for equipotential line, if the velocity potential points are equipotential, then for equipotential lines, your pi, that is velocity potential pi, will be equal to constant. So if the pi is equal to constant, when we differentiate the pi, we get 0. That is d pi is equal to 0. But we know the pi is a function of, for a two-dimensional flow, the pi is a function of x comma y for a two-dimensional steady flow. So what happens is, we can rewrite this d pi. So d pi is equal to dou by dou x of pi into dx plus dou pi by dou y into dy. So that is nothing but, we know dou pi by dou x, that is we know minus u is equal to minus dou pi by dou x, and v is equal to minus dou pi by dou y. So we will substitute these values. We get minus u into dx minus v into dy. Now for the equipotential line, this d pi is equal to 0. Differentiation of pi, because it is constant, d pi is equal to 0. So this is equal to 0. So what we get is u into dx plus v into dy is equal to 0. Now, taking the slope of the equipotential line, we know slope is nothing but dy by dx. We get dy by dx will be equal to minus u by v. So this is called slope of the equipotential line. Okay, so equipotential line means everywhere throughout the line your velocity potential is equal to 0. Velocity potential is constant. So since it is constant, its a derivation is equal to 0. We are rewriting this d pi so that in terms of u and v, we get the slope of the equipotential line dy by dx is equal to minus u by v. Very, very important. Dy by dx for an equipotential line is equal to minus u by v. Now, similarly, we will find what is constant for streamline. So, the line having constant stream function is called line of constant stream function. So, we are going to see what is line of constant stream function. So, for line of constant stream function, our psi will be equal to constant. So, if psi is equal to constant, differentiation of psi will be equal to 0. Now, we know that is dou psi by dou x is equal to v and dou psi by dou y is equal to minus u. So, substituting these, we will rewrite this d psi. So, we get d psi is equal to dou psi by dou x into dx plus dou psi by dou y into dy. So we get this is nothing but substituting dou psi by dou x is v. So we get v into dx. Dou psi by dou y is minus u into dy. So from this, by taking the slope of the streamline is dy by dx, and this is equal to 0, right? Because psi is constant, d psi is equal to 0. So dy by dx will be equal to v by u. Okay. So this is called the slope of the, very important, slope of the constant stream function. So from this we can conclude for an equipotential line. For an equipotential line, slope dy by dx will be equal to minus u by v, and for a line of constant stream function, the slope dy by dx is equal to v by u. So very important. Okay. Now we will just to see slope of the equipotential line is minus u by v. Slope of the constant stream function is v by u. So multiplying both, we get minus u by v multiplied by v by u. So that is equal to minus 1. Which means if you draw the equipotential lines and streamlines, these two lines will be orthogonal. Okay. So equipotential lines are orthogonal to streamlines at all points of intersection. So at any points of intersection, if the equipotential line and the streamlines meet each other, they will be perpendicular to each other. So anywhere if these 2 points, these 2 lines are meeting, that they will meet at 90 degrees. They will be orthogonal to each other. Okay, next is flow net. So what do you mean by flow net? Flow net, it is a grid obtained by drawing a series of equipotential lines and streamlines. So you draw a series of equipotential lines and streamlines, you will get a grid-like pattern. And this grid pattern is called flow net. And this is an important tool in analyzing two-dimensional irrotational flow problems. Very important in while you go for your research in fluid mechanics or hydraulics. Okay, so that is called flow net. Now, what is the relationship between stream function and velocity potential function? So we know for the velocity potential function, we know our u is equal to minus dou pi by dou x and v is equal to minus dou pi by dou y. Similarly, for a stream function, u will be equal to minus dou psi by dou y and v will be equal to dou psi by dou x. So what we have is, see, from these two relations, what we get is u will be equal to minus dou pi by dou x, that is equal to minus dou psi by dou y, and v is equal to minus dou pi by dou y, that is equal to dou psi by dou x. So from this, what we can observe is dou pi by dou x is equal to dou psi by dou y, and dou pi by dou y is equal to minus dou psi by dou x. Okay, so this is the relationship between the streamline function, relationship between stream function and velocity potential function. Velocity potential function is pi and stream function is psi. So the relationship between psi and pi. Dou pi by dou x is equal to dou psi by dou y, and dou pi by dou y is equal to minus dou psi by dou x. Now we will move on to our problems. So our first problem based on this velocity potential and stream function is, our first problem is the velocity potential function pi is given by an expression pi is equal to minus x cube y by 3 minus x square plus x cube y by 3 plus y square. Find the velocity components in x and y direction. Show that pi represents a possible case of a flow. So we can substitute the formula and we can find the velocity components in x and y direction. So velocity component in x direction is u, velocity component in y direction is v. Now in order to show that it represents a possible case of flow, we need to prove that it satisfies the Laplace equation. Okay. So first of all, we will do case 1. We have to find the velocity components in x and y direction. We need to find what is u and v. So we know u is equal to minus dou pi by dou x. So it is minus dou pi by dou x. Pi is equal to minus xy cube by 3 minus x square plus 3x square. Sorry. Minus xy cube by 3 minus x square plus x cube y by 3 plus y square. So differentiating this with respect to x, we get minus of minus y cube by 3 minus 2x plus three x square y by 3. Here we don't have x term, so that will be equal to 0. So we get y cube by 3 plus 2x minus x square y. So this is our answer. U is equal to y cube by 3 plus 2x minus x square y. So this is our velocity component in x direction. Now velocity component in y direction. That is v is equal to minus dou pi by dou y. So what we get is, we will differentiate this minus dou pi by dou y. So it is minus 3xy square by 3. We don't have y term here, so it is 0. Here it is plus x cube by 3 plus 2y. So what we get is xy square minus x cube by 3 minus 2y. So our velocity component in y direction is v is equal to xy square minus x cube by 3 minus 2y. Now we need to prove this is a possible case of flow. So second case, we need to prove this flow satisfies the Laplace equation. Okay, so we have to prove the flow satisfies Laplace equation. So what is Laplace equation? We know Laplace equation is dou square pi by dou x square plus dou square pi by dou y square is equal to 0. Okay, now So let us prove that, right? So that is nothing but, okay, first of all we will write what is pi. Pi is equal to minus x y cube by 3 minus x square plus x cube y by 3 plus y square. Okay. Now, so this is nothing but dou by dou x of dou pi by dou x plus dou by dou y of dou pi by dou y. So what we get is dou by dou x of, what is dou pi by dou x? We will differentiate this with respect to x. So we get minus y cube by 3 minus 2x plus 3x square y by 3. There is no x term here, so that becomes 0. Plus dou by dou y of, we will differentiate this with respect to y. So we get minus 3x y square by 3. Here we don't have y term, so that becomes 0. Plus x cube by 3 plus 2y. So which implies we will differentiate this with respect to x. So dou by dou x of this term plus dou by dou y of this term. So we get, when we are differentiating with respect to x, we get, so here we don't have x term. Here it is minus 2. So we will remove this. So this is equal to, right? So this is equal to here we don't have x term, here we have x term. So minus 2 plus 6 xy by 3. Here it is, we can cancel, sorry. So here it is minus 2, we can cancel 3. So we get 2xy. Here we are differentiating with respect to y. So we can cancel this. So we get minus 2xy. We don't have y term here, so that becomes 0. Here differentiating with respect to y, we get plus 2. So that is equal to 0, which implies Laplace equation is satisfied. So if Laplace equation is satisfied, that means it is a possible case, which means it is a possible case of fluid flow. So possible case of fluid flow. So in order to prove there is a fluid flow, we need to prove it satisfies the equation, that is the velocity potential satisfies the Laplace equation. We will move on to the next second problem. So second problem is the velocity potential function is given by pi is equal to 5 into x square minus y square. Calculate the velocity components at the points 4, 5. So here we have, it is a two-dimensional flow. So directly you can substitute and you can find the answer. Okay. So it is given the velocity components u will be equal to, velocity component u will be equal to, we know u is minus dou pi by dou x. So we get minus, with respect to x, we get minus 5 into 2x. So substituting x is equal to 4, It is minus 5 into 2 into 2, sorry 2 into 4. So we get minus 5 into 8. We get minus 40 units. Similarly, our V will be equal to minus dou pi by dou y. So it is minus of dou pi by dou y, we get 5 into minus 2y. So we get 10y, substituting y is equal to 5, we get 10 into 5. So it is 50 units. So that is our answer. Now we will move on to our next problem. Next problem is a stream function is given by, see previous two problems were velocity potential function was given. Here stream function is given. So stream function is given by psi is equal to 5x minus 6y. Calculate the velocity components and also calculate the magnitude and direction of the resultant velocity at any point. So now it is given, here it is given psi is equal to 5x minus 6y. We know u is equal to, u is given by minus dou psi by dou y. So it is minus of dou psi by dou y, it is minus 6. So it is 6 units per second. Now similarly v is given by dou psi by dou x. So that is equal to 5 units. Now our resultant velocity v will be equal to square root of u square plus v square. So we get square root of 6 square plus 5 square, that is equal to 7.81 units per second. Here also units per second. Okay, so we are asked to find the magnitude and direction. Now how will we find the direction? Direction means we have to find the angle theta. So tan theta is equal to v by u, which is equal to v is 5 and u is 6. So we get 0.8333, from which we get theta is equal to 39 degree 48 minutes. So this is our answer. The direction is 39 degree 48 minutes. Direction of a fluid flow. See, that means your u is positive. Both are positive, right? So, okay, so no issues, right? So u will be 6 units per second and v will be 5 units per second. And the resultant velocity v will be 7.81 units per second and theta will be equal to 39 degree 48 minutes. Okay. Now we will move on to the next problem. Fourth problem. So the problem is, if for a two-dimensional potential flow, the velocity potential is given by pi equal to x into 2y minus 1. Determine the velocity at point 4, 5. X is 4, y is 5. Determine also the value of stream function psi at the point. So very simple. So first we will determine the velocity at the point 4, y. So for that, see, you can solve this problem. I will give you the hint. You do this as a homework problem. So your pi is given as x into 2y minus 1. So first of all, you find what is u, that is equal to minus dou pi by dou x. We get 1 minus 2y. You substitute the value for y is equal to 5. You get u will be equal to minus 9 units per second. Similarly, our v will be equal to minus dou pi by dou y. So that will be equal to minus 2x. So substitute x is equal to 4. You get minus 8 units per second. Now our resultant velocity v will be equal to square root of u square plus v square. You substitute the value, you will get the resultant velocity at point P is equal to 4, 5 as 12.04 units per second. So this is your first part. Second part, you need to find the stream function also. So for finding the stream function, we will do it in detail. Okay, that is our second part. So now we know our stream function, that is dou psi by dou y is equal to minus u. So u is nothing but minus of 1 minus 2y. 1 minus 2y, this value. U is equal to 1 minus 2y. So substituting okay, don't substitute, we get 2y minus 1. Similarly, we know dou psi by dou x is equal to v. So we know v is equal to minus 2x. Now in order to find psi, we will differentiate. So we will take this as equation number 1, this as equation number 2. Now we will integrate equation 1. Integrating equation 1, we get integration of dou psi is equal to integration of 2y minus 1 into dou y. So when we integrate, we get integration of dou psi is psi is equal to, we integrate this with respect to y, we get 2y square by 2 minus integration of 1 is y plus we get constant of integration. So now see, we are integrating with respect to y. So your constant of integration, this constant of integration will be a function of, this constant of integration will be a function of x. It cannot be a function of y. Okay, it can be only a function of x. So now, so we will take this constant of integration as k. We will take this constant of integration as k. Okay, we will take this constant of integration as k. So what we get is psi is equal to 2y square. So we can cancel 2, we get y square minus y plus k. Now we will differentiate this with respect to x. Okay, we will take this as equation number 3. So we will differentiate this 3 with respect to x. Okay, we have only some space. Okay, so now differentiating this with respect to x, we get dou psi by dou x is equal to dou k by dou x. But from equation 2, we know dou psi by dou x is equal to minus 2x. So this value is equal to minus 2x. So minus 2x is equal to dou k by dou x. Now again we will integrate this. What we get is integration of dou k is equal to integration of minus 2x into dou x. So what we get is integration of dou k is k. That is equal to integration of minus 2x is minus 2x square by 2. So that is equal to minus x square. So value of k is minus x square. That means our equation number 3 becomes psi is equal to y square minus y minus x square. So this is our stream function. Now at point P is equal to 4, 5. Our psi will be equal to 5 square minus 5 minus 4 square. So we get psi is equal to 4 units. So this is our answer. Okay, we will move on to the next problem. Our fifth problem is the stream function for a two-dimensional flow is given by psi equal to 2xy. Calculate the velocity at the point P of 2, 3. Find the velocity potential pi. So you can solve this as usual. I will give you just the answer. You can take this for practice. So your answers are, see, psi is equal to 2xy. U will be equal to, the value for u is minus 4 units per second. The value for v will be equal to 6 units per second. The resultant velocity v will be equal to square root of u square plus v square, and the answer, the value is 7.21 units per second. Now the velocity potential, you will get the velocity potential pi is equal to 2x square by 2 plus c. That is x square plus c, where c is the constant of integration. Anyway, see, I will do this part for you. Sometimes you may get confusion. See, up to this you can do. After this, you find v is equal to 7.21 units per second. After that, see, it is dou pi by dou x is equal to minus u. So you get minus u will be equal to, see, u is minus dou pi by dou x. So you get minus of minus 2x minus dou . Okay, stream function is given. So dou psi by dou x is equal to v, and dou psi by dou y is equal to minus u. So our u will be equal to minus dou psi by dou y. That is why it is minus of u is minus 2x. Similarly, our dou pi by dou y is equal to minus v. So we get minus of, see, v is dou psi by dou x. Dou psi by dou x we get 2y. So it is minus 2y. So now we can integrate. We can integrate this equation. We will take this as equation number 1. So integrating 1 we get integration of dou pi is equal to integration of 2x into dx, from which we get pi is equal to 2x square by 2 plus c, that is equal to x square plus c. We take this as equation number 3. This we will take it as equation number 2. So what we get is, in order to find c, we will take dou pi by dou y is equal to dou pi by dou y is equal to dou c by dou y. But we know what is dou pi by dou y? It is minus 2y. So that is equal to minus 2y, from which we get dou c by dou y is equal to minus 2y. Now integrating, we get integration of dou c is equal to integration of minus 2y into dou y. So from which we get c is equal to minus 2y square by 2, from which c is equal to minus y square. So substituting this value in equation 3, we get pi is equal to x square minus y square. So this is our required answer. Okay. Now we will move on to our last problem. So our last problem is sketch the streamlines represented by pi is equal to x square plus y square. Also find out the velocity and at its direction at 1, 2. So how will you do this? So it is given psi is equal to x square plus y square. So our velocity components are u is equal to minus dou psi by dou y. So we get minus dou by dou y of x square plus y square. It is equal to minus 2y. This term becomes 0 because there is no y, only this term, so it is minus 2y. Similarly, our v becomes dou psi by dou x, that is equal to dou by dou x of x square plus y square. We get 2x. So at points 1, 2, right? So substituting x is equal to 1 and y equal to 2, we get u is equal to minus 2 into 2, that is minus 4 units per second, and v is equal to 2 units per second. Therefore, our resultant velocity v is equal to square root of u square plus v square is equal to square root of minus 4 the whole square plus 2 square. We get 4.47 units per second. Now, for the direction, we know theta is equal to tan inverse of v by u, or tan theta is equal to v by u. So, substitute, we get theta is equal to 26 degree 34 minutes. That means, see, our u is minus 4, right? U is minus 4, which means u will be in this direction. That is why it is minus 4. So 4 units per second. And v is 2, so it will be in this direction. That is 2 units per second. So the resultant velocity will be in this direction. So the resultant velocity is 4.47 units per second, and theta will be with respect to x-axis, and that is equal to 26 degree 34 minutes. Now we have to sketch the streamlines. Okay. So we know, see, this psi is given as x square plus y square. So psi is given as x square plus y square. Now substitute this psi is equal to, substituting psi is equal to 1, 2, 3, etc. What we get is 1 is equal to x square plus y square, 2 is equal to x square plus y square, 3 equal to x square plus y square, etc. So each equation, see, all these equations are equation of circle. So now equations of the circle, and see, from this equation we can say that we get concentric circles of different diameters. So when we draw these stream functions, when we draw these streamlines, we will have concentric circles. Okay, we have concentric circles. This is our x direction and this is our y direction. So concentric circles, the equations of the circle is, here it is x square plus y square is equal to 1, x square plus y square is equal to 2, x square plus y square is equal to 3, and etc. It goes on like that. So that is all. Now we have completed our module 2 with this. So in the module 2 we have seen what is metacenter, we have seen what is metacentric height, and we saw the analytical method of determination of metacentric height, the experimental method of determination of metacentric height. We saw the problems related to that. After that, we saw the kinematics of a fluid flow. And in kinematics of a fluid flow, we saw what is a Lagrangian method of description of a fluid flow and Eulerian method of description of fluid flow. After that, we saw what is continuity equation. And before that, we saw the types of fluid flow, that is a steady flow and unsteady flow, uniform and non-uniform flow, rotational and irrotational flow, two-dimensional, three-dimensional flow, then turbulent and laminar flow, compressible and incompressible flow. After that, we saw what is continuity equation, and we saw Q is equal to AB, or Q is equal to rho AB. Then we saw the application of continuity equation for the fluid flowing through pipes. After that, we saw continuity equations for 1 and 2 dimensions. Then we saw what is acceleration and velocity of a fluid flow, the velocity potential function, stream function. Then what are the properties of velocity potential function and stream function? How does it satisfy the Laplace equations? What is the condition to prove the flow is irrotational? Then what is flow net? What is equipotential line? And what is constant streamline? And we saw problems related to this. So with this, our second module has been completed. We will move on to our third module in the next class. Thank you.